everyone. There was a power interruption a while ago when I was doing my uh, EDA on normal distribution and exponential distribution. I did not touch exponential yet. I was just in the normal distribution topic when when there was a power interruption. So I'm back again, and I am doing all over again. So here I am. I'm just going to share my screen. If you want to see what I am doing, the actual calculation of the normal distribution, the normal probability distribution, you can see it from Wonderful Mommy Debs, DEB with a Z at the end. Okay, so I'm now going to start my lecture. I'm going to share the entire screen. And I have to change my layout. So that's it. Right. Hello. Thank you for watching. And I'm just going to do the live discussion of normal distribution. And where is that normal distribution? Yeah. There was a power interruption this afternoon, kaya I wasn't able to finish it. So now I'm going to continue with it. As you can see from my screen, I have here a power distribution curve. Okay, I'm just gonna remove all the yellow lines here because this was what I was discussing today. Now, I will make it as short as I can. So here is a normal probability distribution. What does it mean, normal probability distribution? It is composed of a symmetrical curve here. Why is it symmetrical? Because at the middle is the average of all the values that you're going to analyze. And from the middle, you go one sigma away and another sigma away. So there's a 2 sigma and another sigma away. That will be 3 sigma. And when you go left, it's negative 1 sigma, negative 2 sigma, negative 3 sigma. And the rest of what I'm shading now, the rest of the curve, that will be for the positive infinity at the right and negative infinity at the left side. Okay. So just not to confuse you, then I have to remove all these shades in here so we can do it properly and neatly. And also you can observe from here that from the middle line, you have similar or exact values left and right of the middle line. So let me just shade the middle line with another color. This is the middle line, yeah? I think it's better if we're going to use the green one. There. More distinct, right? There. So at the middle line, you have 34.134 on the other side and on this side, on the left side. And then if we continue, we have 13.571, 13.591 on the other, between 1 sigma and 2 sigma, and it's negative equivalent. And you have 2.14 here and a 2.14 there. And you have 0.135, that is the remaining bit of the 50%, and this is the remaining bit for the 50% on the other side. That's why it's called normal probability distribution. You must know this by heart if you want to memorize the values, or you must have a copy of it so you can use it during the exam. Right. Let's go to the next one. I will clear my words later. So in the normal distribution analysis, you'll be using two methods by formula where you have to integrate from A to B, and you have to use the normal distribution curve. Right. You have seen a while ago the normal distribution curve where the 68% area was distributed on the blue side, on this side here. Oh, you cannot see it. On this blue side here and here. And the 95% area distributed on those. Okay, I'll put two dots here. And then here will be the three, the third one. And of course, those bits there. Yeah, which will never cross each other. Okay, I'll make it better. I will just extend this one and this one. Of course, that is a horizontal line to the left. And this approaches positive infinity, and this one is negative infinity. Now, the middle one, the middle line, the one that I have stressed a while ago, the middle is the mu. Okay, the 68% is actually not 68 exact 68, but it's 68.268. So it was distributed like 68.268, the half of that. Let's calculate. I just want to move this one here, the calculator. Okay, so if we have 68.268, you divide that by 2, then you have 13.134 on the blue line, okay, or on the blue area. So here is 13 this one, 13.134. 134. Did I write it correctly? 34, I should say. 34.134. What am I saying? It's 34.134. Okay, here is also 34.134. They're all in percentage. Okay. And then on the two green area, it's the 95.45. So you have to, because that this area here is all 95.45. All you need to do is to take away all you need to do is to take away 95.45, take away 68.268, and you have to divide that by 2. So it's 13.591, and you had seen those values when I'd shown you the normal curve the first time, right? Okay, so this is 13.591. These are all in percentages. Okay, now the next part of the normal curve will be the 97.73 area. So what you will do with that is 99.73, I should say. 99.73 area minus 95.45. Whatever is the remaining, you have to divide this by 2. So you have 2.14 on each side. So this is 2.14. And this is 2.14, the yellow bits. There you go. And the remaining will be the 100% minus 99.7. So 100 minus 99.73, that's the exact value. So you have 0.27 divided by 2. So you have 0.135 on each end. What does it mean? That area that approaches negative infinity will be 0.135%. And that area that approaches positive infinity over here, you do not know where it ends, but that will be until infinity, because the whole of that will be 100%. Yeah. So we are done with the distribution of our 68, 95, or 99.7 area. We will be using this for the first example. And to the rest of the calculations that you will be doing, that makes use of normal distribution. Okay, so I'm going to copy this one because we will be needing the percentages for the example. Right. So here is now the problem statement that we're going to do. For problem number one, it says here, what percentage of the class has a test score between 59 and 83? What is this class? It's an EDA class with 60 students, had an average score of 75, and the standard deviation of 8. What does it mean? The 60 students took their exam, and the average score of all those 60 is 75. So if we put it into our curve, okay, let me just remove that. So if we put it into our curve, the mu is 75. I hope you are with me. Uh, yeah, mega love shout out to Marites Valdez Ruyan from Rojas Isabela, the treasurer. She's a CPA and she's a treasurer of Rojas Isabela. Hi JD, I'm doing my lecture here in EDA, because I know that weather is not really cooperative and the exam has been moved. So I guess the best help I can do is to do um, what's that, an online or a live discussion, whether they are there or not. I'll just have to send the link later for them to go through it. Anyway, good evening to you, Gov, John Dave. Sorry, Rod Gallardo, if you're watching, yes, please go to my YouTube channel if you have enough, what's that, credit, or you don't have EDA, right? You only have statics and you have the differential equations with me. I also forwarded those to you already. I made two videos today. This is the third one. All right. So, Wens Bulawitan. Okay. Thank you so much, Wens. Where are you now? Are you still in Dubai? Yeah. How are you? How are you? Are you okay? Let's talk. Yeah, later. Okay. Get in touch or keep in touch. Okay, Wens. Right. So, for those who are with me now in EDA, so we're going to continue. It says here there are 60 students, and then the average score is 75. The standard deviation is 8. What does it mean? If we're going to start with the mu, which is 75, mu is the average. Okay. If you read the word average, that is always the mu in statistics or in EDA. And then because there is a standard deviation of 8, so for every slot from 1 sigma to 2 sigma to 3 sigma, and then negative 1 sigma, negative 2 sigma, negative 3 sigma, the except except the 0.135% area and the one at the left as well towards the infinity, except this one and except this one, all the distances between sigmas will be 8. So what does it mean? From 75 to 1 sigma, then that must give us, I want a yellow one. Okay. That must give us 83. Oh, you cannot see that one. That's not a good choice of pen, right? Blue or green. So it must give us 83 here. Can you see that? Or I can just write it down below so you can, because it's too cluttered if I put there. So that will be 83. 75 plus 8, that will be 83, plus another 8, that will be 91. In the 2 sigma position, in the 3 sigma, plus 8 will be 99. Okay, towards the positive infinity, of course, that will be 100. And as we go down, 75 minus 8, that will be 67. Am I right? Because 67 plus 8 is 75. 67 minus 8, that will be 59. And then 59 minus 8, that will be 51. Okay, let's see. 51 plus 8, 59 plus 8, 67 plus 8, 75. Okay, so 75 here is a superstar, I would say, because that is where we reckon all our computations for the percentages in each sigma position. Right, we're going to do the calculation of letter A in 2 ways. One by formula and one by the curve. Okay, so again, it says 60 students are there, average is 75, standard deviation is 8, and we have plotted them very clearly in our normal distribution curve. Let's go now to letter A. What percentage of the class has a test score between 59 and 83? Okay, between 59 and 83. So P, and here will be your X between 59 and 83. Because that is a range, then we have to use a proper inequality symbols. 83 is included, so that would be less than or equal to 83. And my X should be greater than and equal to 59. What does it mean? So you're going to get the probability density of X that is less than or equal to 83. So 83 is included, and X greater than or equal to 59. How did I read it? You have to read it from X. Okay? You have to read it from the position of X. X is less than or equal to 83. X is greater than or equal to 59. So that's how to read the range. So from 59 to 83, therefore, will be these percentages. From 59, it's negative sigma. To 83, that is the plus 1 sigma. And what are the percentages included? The one that I have shaded. So we're going to write in 13.591 plus 34.134 and 34.134. That is actually 68. Where am I? 68.268. Okay. Plus 68.268. That's it. And what would be the percentage of students having a score from 59 to 83? What's the percentage of the class? So we're just going to calculate using my calculator here, 68.268. So that would be 81.859. So that's the answer. 81.859%. That's what it means. Yeah? 81.859% of students garnered a score of from 59 up to 83. Okay, so if you're going to ask maybe how many students are there, you just have to multiply 0.81859 by 60 and you get the number of students. Maybe try that one. So 0.8 0.81859, multiply it by the number of students, 60, and this will be the number of students who had a score from 59 to 83. Let's calculate. So you just have to divide that by 100 so that you will have a decimal, and then times 60. Bang you go. You have 49.1154. So that would be 49.1154. I'll just approximately 49 because there's no 0.11 or 0.12 percent. So there were 49 students whose scores are from 59 to 83. Now, this time we're going to do the next method. So let me just clear this out. That the first method is, this is method 1. The first method is by the curve, and the second method will be by formula. For the formula, you have to use your calculator. Okay, I have the formula here, up here. So let's do the percentage or the probability density notation. So that will be 59 less than equal to x less than equal to 83, I should say, not 89. I'm sorry for that, 83. Okay, so how do we read again? We start reading it from x. What is the probability of the class X that has scores less than or equal to 83 or greater or equal to 59? Okay, don't say the scores less than or equal to. No, you are referring to x. And if you refer from x, this, oh shush, sorry for that. This is the range that you are trying to read, because students always make mistake. X is less than or equal to 83, x is greater or equal to 59. Okay, so let's use the formula. So this will be equal to, you have to put an integral sign here, from 59 to 83. And that will be e to the negative x minus mu, that is 75, square over 2 times 64, because 8 square is 64, isn't it? There. And then you have to divide everything by by sigma. Sigma is 8, square root of 2 pi. When you are using annotation pi, your calculator must be in the radian mode. Okay, don't attempt to use degree mode, because it will never be the right, and you'll never get the right answer. Okay, so the answer should be the same. And with this, I have to show you how it's done through the calculator. We must get the same 81.859 using the calculator, okay? Right. So we have an integral here. You have to bring in the integral there. And then the lower limit, let's put in the lower limit straight away, because it's so difficult to be going around when everything is already put in, especially this entails e and powers and all. So that would be from 59 to 83. That is the limit. And go to, hang on. Okay, now go to the integral, to the integrands, I should say, and it's a fraction. And the power is an e, so that is inverse ln. And the power is a negative, and then open bracket, you have an x, the variable x is an alpha x. Okay, and then minus 75, close bracket, a square, and then you have a division, you have to divide it by 2 times 64. You can actually do 128 straight away, right? 128. 64 times 2. Okay, and then you go down and type in 8 square root. For those who like to see what I am lecturing, you can go to my YouTube channel. It's Wonderful Mommy Debs, Debz. Okay, Mr. Mangada. Big love shout out to Lenlen Tagakay, who is in Oman. All right. So I'm doing my lecture in normal probability distribution for my second year engineering students. Right, so that would be 8 the square root of 2. Let's continue. Oh, sorry. It didn't go through. Okay, 2 and then pi. Look how it's written. You have a limit of the integration. You can only do this one, the definite integrals, quickly. And of course, it's so difficult for you to do the e to the negative x and so on. So this is a calculator work. Method 2 is calculator work, definitely. Once you have put in all the elements of your equation, then you just have to click equals and bang you go. It must be the same, okay? In the manual calculation, we got 81.859. And this one, we also got the same. It's 0.815, but it's in decimal. It should be in decimal. 856 actually. 859 is the same. 81859. There you go. Now, if you multiply this by 100, then you get the same 81.859% as well. Okay? So this is why I'm saying there are two methods that you can use in normal probability distribution. You can use the graph, you can use the normal distribution curve, that's method 1, and the other one is by formula. Okay, so the formula and the curve, you can put it in a piece of paper maybe, but don't make it too obvious because the proctor might say that that is your código, but you can put it in a piece of paper, a small one only, that would be allowed in the exam, because I know that you cannot memorize all these powers and all, yeah? Okay, I want to stress as well in the E formula, the X in here will just be an X. You don't need to fill in anything in the X, okay, because this is a range, all right? This is a range of values, so the calculator will do its work for you. Right, so that is just letter A of the questions. What percentage of the class has a test score between 59 and 83? Now we go to how many students got a test score between 75 and 88. Right, for this one, you just have to get the range from 75 to 88. 88 is not there. Oh, I'm going to change this question. Instead of 88, I'm going to change it to 91, okay? Because there's no 88 in here. You cannot say from here, otherwise you would just be using the formula. If and when the range, the possible range is stated, and you cannot use two methods, because how are you going to approximate the 88, right? So it should be something that can be seen from your curve. From 75 to 91 is very evident. So you can just do 34.134, 30.591, and that's it, right? And then your range, when you're going to do the formula, it will be 75 to 91. That will be your lower limit, up to 91, your upper limit. Okay, now for question C, how many students have a test score greater than or equal to 88? Again, the 88 is not there. I'm going to change that to 91. Okay, a test score greater or equal to 91. So how will you do that? Greater or equal to 91. You have to get a range from 0 to 91, and then you take that away from 100. Or you can do 91 to 100 as well. Okay, so let's do that. Let's do letter C, because for letter B, I have already done an example for you. So it's similar to letter A, and then for the number of students, you just have to do it this way. Whatever percentage you had calculated, both methods, then you just have to make that percentage to decimal, multiply it by 60, and then you get an approximate value of the number of students, like what I have in here. And I had already shown you earlier on. I don't need to repeat that. So we need to go to letter C instead. Right, for letter C, how many students have a test score greater than or equal to 88? Oh, I have changed that to 91, right? 91. Okay. But I need this full stuff in here. So hang on, I have to take this because I need the percentages. Okay, here. I'll take that meantime, take that away and put this in. All right. In two ways, how many students have a test score greater than or equal to 91? So, greater than or equal to 91 by using the curve. So I'll put an X here. Greater or equal to 91. Oh, there's no lower limit, wasn't it? So we can just do like this. X greater or equal to 91. What would it be? Okay. So 91 from here to infinity, that will be 2.14 plus 0.135. Okay. So those are the only percentages included in the 91 and above. We have 2.14 plus 0.135. So to calculate that, okay, that could be easy, but I'm just going to use my calculator here. So you have 2.14 plus 0.135, and that gives us 2.275%. Okay. Now, how many students? That's not still the answer. We just have taken the percentages from the class with a mu or an average of 75. So from here, you will now multiply 0.2275 to 60. So the number of students who got a score 91 and above, 91 to 100, will be 0.2275 times 60. And you'll get the number of students from here. So that will be, this is percentage, the one that you are seeing from the calculator. Divide everything by 100, so you get 0.0. What happened? 0.02275. Hang on, let me just calculate that again. You have to divide it, right? So 0.2275, I'll just put it in like that, times 60. Oh, no. That's wrong. Sorry. That should be, you're going to move the decimal twice. 0.02275 times 60. So that would be 1.365, or let's say approximately 2, because 0.36 is already near half. So there are almost 2 students who got a score of 91 and above. Okay, so how did I do that? Because this is a percentage, then you have to divide it by 100. Dividing it by 100 means you're going to move the decimal place twice to the left, 1 and 2. That will be the position of the decimal, and then you put a 0 there and a 0 there. So it's that is 0.02275. Okay. Now, if you're going to use the the formula. So it will be p x greater or equal to 91 is equal to from 91 to 100, because we are talking about greater than 91. Okay, so from 91, greater than or equal to 91, I should say. So 91 to 100. Greater than 91 will start from 91.1, 92.2, 92.3, and so on. Or if they will be in whole numbers, of course, you jump into 92 straight away up to 100. So let's put in the formula here again. Once again, you have an E minus, the X will still be an X, minus 75, that's the mu, square root, sorry, square, divided by, the exponent will be divided by, sigma is 8, 8 times 6 is 64, 64 times 2, that will be 128. All right. And then everything divided by sigma is 8, the square root of 2 pi. We must get a percentage here similar to 2.275. Let's do it. All right. So again, if you are looking at my calculator, then we have to bring in our integral, and we're going to fill in our boundaries, 91, the lower bracket, and the higher bracket or higher boundary will be 100 from 91, the limits, I mean 91 to 100, the limits or their boundaries. So okay, so we need a fraction here, and that will be shift ln, that will be an e, a negative, an open bracket, alpha x minus 75, close bracket, square. And you have to divide whatever you've got there for the power by 128. Oh, I did a double division, 128. And then you go down and type in 8, and then a square root, that will be 2 inverse times 10. And you notice that this is actually with a dx because it's an integration. All right. And then you press equals, and there you go. You have 0.022. This is 0.0286, but up to the one, hang on. What I'm saying 0.022, okay? So you have 0.022 up to the third significant figure, then the value is the same. Up to the third significant figure, 1, 2, and 3, the values are the same. So you will not expect that all values will be exactly the same, because in the curve, those are all approximations. If you had seen, or if you have watched the early part of my video, it says there's 68% area, but that is actually 68 point. What's the point in there? 68.268%. So imagine the 0.268 that was not included when they defined it. Then that will give you a difference, or 95% area, which is actually 95.45, or 99.7, that should be 99.73. So all these estimates will have an effect in your final answer. However, you can peg into the number of significant figures that you're going to use to make them the same. Like what I did, I can get 0, hang on, I can get the 0, the 2, and the 3, or 0, 2, 2 actually. So it will give you 0, 2, 2 as well for the other method. I know that this will be 0.023, but due to rounding off, that's why there is a value. Let's just use the more conservative number that is lower in percentage. All right, so that's how it is when you talk about greater than. Actually, there's another method to do this one. You can do 0 to 91. All right, you can have a limit of 0 to 91. Your integral will be, let me just put it here. You can also do the integral from zero to 91, and then get the value there, and then you do 1 minus. Okay, what happens is from 0 to 91, that will be all less than 91, and what you are interested in is the greater bit of it. So from 0 to 91, for example, this is what you're going to compute, but until this part is 100%. So 100 minus 0 to 91 calculation, then you get the 91 and more, or 91 to 100 values. Okay, so there are three ways actually when it comes to equalities or inequalities, like less than, greater than, or equal to. Okay, I hope that this is very clear to you. For the EDA people, then I will be giving this copy for you to go through it. Now, the next thing we have to do is the exponential. I just have to do the next one, jump into the next one instead, because this is anyway easy to understand as well. Right. So we now move on to exponential distribution. It's a right skewed distribution, continuous probability. So this is like, um, let me just compare it with the normal distribution. For the normal distribution, you have this bit here. Oh, hang on. Okay, exponential. Right. For the normal distribution, you have the complete bell shape, the bell shaped curve, right? Now, in the exponential, you will be concentrating on this parabola, this bit. Okay, so it says here that exponential distribution is a right skewed continuous probability distribution that models variables in which small values occur more frequently than higher values. Because in the exponential distribution, you are going to concentrate on that line that goes to infinity, positive infinity. Okay, so this part here is your concentration, the small amounts, okay, the small values. So when the small values become the superstar, then you have to subject your analysis to exponential probability distribution. Now in the in the exponential, all you need to do is all you need to do is um, here you go. All you need to do is to graph this one, find for uh, the rate parameter, which is represented by the lambda. This one, the lambda. The lambda is always the reciprocal of the average. Okay, and then you have to subject it through a formula as well, right? So that's all you need to do in exponential distribution. Okay. Um, Now let's have an example here. Say you have computers produced by ABC, as you can see from the problem statement, and computers produced by ABC company last on average for 8 years. The lifespan of each computer follows an exponential distribution. So it means there is a continuous progress, but it's just little amount every period included. So one, calculate the rate parameter. Okay, so rate parameter from our formula. Rate parameter will be lambda equal to 1 over, what is the average? The average given is 8. Okay, so 1 over 8, that will be 0.2. Okay, let's calculate that again. 1 divided by 8, that is 0.125. Sorry for my calculation. Okay, 0.125. I made a mistake there. 0.125. Okay. There's something that is toying in my mind. It's not. It's not the point two. Sorry, it's not the 1 point. It's not the point. It's the 0.125 that must come out from my mouth. Right. What is this lambda doing here in the calculation? As I've said, there are three things that you have to do in the exponential distribution, right? So you have the lambda, which is from my graph, it is seen in here is 0.125. There you go. But you can put it here, but it's a bit cluttered, so I put it there. There. And then your average is, what's the average again? It says here average of 8 years. There you go. And it's always skewed to the right. This is the little bit that you can see from your normal curve. Okay, this is towards positive infinity. We don't analyze the negative. So the second one is the formula, lambda e to the negative lambda x. Okay, so let's have the first, or letter B now. Letter B says, what's the probability density function, and graph it. Okay, there you go. I have already graphed it. This is the average. This is 8 years, and then positive infinity and 0.125 for the lambda. So that is the answer for letter B. So we're done with that. Right, letter C says the probability that a computer will last less that will last less than 5 years. Okay, so the computer that is lasting for five years. So 8 is here, so 5 could be here. 5. So we are interested with this little bit here. Yeah, I'm going to shade it with blue. We are interested with this area, and to find that area we have to use the formula. So the formula is lambda. What is the probability density where the computer X can last for less than 5 years? Okay, so you have the lambda of 0.125, and then an e raised to negative 0.125, and an x, the x bit. Okay, so hang on, let me just okay, hang on. Right, give me a second. Hang on. I'm here, okay? I did not go. I'm just checking something. Okay. Where are you now? Oh, I'm here. Okay, let me just share my screen once again. Entire screen. There. Where am I? Exponential. Here, right? Okay. So the calculation would be, we need a new slide there. Okay, let me just take this one here. There. Copy and put it here. Or I'll just copy the entire. Wait. I will remove this one. Because I have shown you already the calculation a while ago. Yeah? There. Right. So we need to get what again? The lifespan of, what's the probability that the lifespan of the computer will last less than 5 years. Okay, that will last less than 5 years. We cannot neglect the other part of the graph. So all we need to do is the probability that it will be less than or equal to 5 years in its existence, or its was that functional life or economic life. Then you have to do 1 minus lambda e to the negative lambda x. So the answer will be x less than or equal to 5 is 1 minus our lambda is 0.125, and then e to the negative 0.125. And how many years was it? Less than. When it's less than, then you do 1 minus less than 5. Okay, so the answer here would be, let's do our calculation here. So that is 1 minus, open bracket, 0.125, and then shift E there, and then negative, that is 0.125, 0.125, and then the x. Our x is actually 5 because we are interested less than 5. Okay, so less than 5 would be 1 minus that. Okay, so we have 1 minus 0.125 up to there. Okay, so let's see what I have written here. 1 minus, I have a bracket, so I'll better put a bracket at the end as well of 5. There you go, and you do equals there. So you have 0.933, or that would be 93.31. So that is 93.31%. Okay. Now, letter B or letter C, the probability that a computer will last more than 8 years. So more than 8 years. Okay, let's copy that and put it here. Okay, we are now in letter B. More than 8 years. Letter C, I should say. Okay, let's remove all the other highlights because we're not interested with that anymore. And here we're not. The graph, we are still going to use that one. Right. So more than 8 years means we are interested with this part because that is more than 8 years. More than 8 years does not need any one minus. So it will be just itself. So the probability for x to be greater than 8 will be a lambda of 0.125 and e a negative 0.125 and an x of 8. When it's less than, then you have to use 1 minus. When it's greater than, then it will just be the formula direct. Okay, so the formula will now be 0.125 e, and that will be negative 0.125 times 8. Nothing more to do. Okay, so it will be 0.045.0460. Okay, if you multiply that by 100, then you get 4.6%. Okay, so that would be the probability density of the computer, 4.6 probability, 4.6% probability that it can last more than 8 years. And for the more than 5 years, it's 93.31%. So it's a good quality of computer because the lifespan will be 93.31% after 5 years. But there's no guarantee that it will be um, it will still be okay after 8 years because the percentage is 4.6%. All right. And then the probability that the computer will last between 3 and, what's the other one? Between 3 and 6 years. Now, this is a bit tricky. Between 3 and 6 years, you have to get the 6 years first. You have to get the 60 years. And then after that, you have to get the 3 years. And then you have to take away the results. Okay. So after 6 years, and then 3 years exact, 6 years exact, 3 years exact, and then take away. Okay. So I have already shown you how to do it. Then I think the 3 and 6 will just be your work. All right then. So I hope you understood how the exponentiation or exponential um, probability distribution is done. Okay, I will forward this to you, and so that you have something to refer from, and it will help you during the exam as well. But of course, it's not similar because you're going to use formula here. That's the only similarity, the same formula, but okay, but as to the what do you call as to the problem statement, it will be totally different. Okay, so thank you so much for watching, and I hope I have helped you when it comes to the four probability distribution. What is your scope? Binomial probability. You have your Poisson, and then you have exponential distribution and normal distribution. There are four distribution topics that you're going to revise on for the midterm exam. And I had already given the we already discussed the two, and the other two I just had discussed it through this video. All right then, so please just go through and then do them again and again and again, so you'll be helped out and you can understand it better when you're going to do it by yourself. Okay. All right. So this is all for now. Thank you so much, and I hope to see you within the week. Within the week, if not during the exam. Bye for now.